स्क्रीन दिसते का बघून मला सांग, मी स्क्रीन शेअरिंग करतोय आता. दिसते का सांग?
नाही सर.
एक मिनिट. दिसते का स्क्रीन?
हाँ
Check.
दिस.
Okay, you
हाँ
can
दिस.
you can start.
स्टार्ट करू सर.
Yeah.
Good morning everyone. Welcome to my seminar. First introduce myself, Miss Shivani Kurade. I am studying in basic EY and today I giving the seminar topic name is intermediate compound formation theory. Next. Intermediate compound formation theory. Less energy consumption and the actual reaction. The intermediate compound being unstable combines with the other reactants to form desired products and the catalyst is regenerated. Usually, homogeneous catalyst follows intermediate compound formation theory of the catalysis. Next. Theories of the catalysis. There are two main theories of the catalysts. Is described as follows. First one is intermediate compound formation theory, and second one is adsorption theory. So today I am giving the first theory. So this name is intermediate compound formation theory. This theory was proposed by Clement and Dizoms in 1806. According to this theory, the desired reaction is brought about by a involving formation of the unstable intermediate compound, followed by its decomposition and its desired end products with the regeneration of the catalysis. Next. Intermediate compound formation theory is originated to proposed by homogeneous catalysis, and according to this theory, the catalyst first forms an intermediate compound with one of the reactants. For example, a reaction in which two reactants A plus B, so it will be get AB, and which occurs in presence of catalyst C, may take place as one of the A plus C which gives to AC. One of the reactant combines with catalyst C and forms an intermediate compound AC. So this intermediate compound is highly unstable, and AC plus B tends to AB. So this intermediate compound reacts with the another reactants and required product. Many catalytic reactions can be explained on the basis of this intermediate compound formation theory. Next. We'll different types of the intermediate compound formation theory. First example is uh, uh, lead chamber process is used as production of the sulfuric acid. So first example is 2NO plus O2. So it will be get 2NO2. This nitrogen oxide gas reacting with dioxygen. So it will be get reaction nitrogen dioxide. So this intermediate compound is occur. Next example, NO2 plus SO2. So it will be get SO3 reacting with nitrogen oxide and sulfuric oxide, giving us the reaction and sulfuric trioxide. And once again is catalyst is obtained. So one more of the catalyst is converted into the many more of into product. Next. Thank you.
If you are having difficulties or doubts, you can ask her. I think nobody is having any difficulty. So Next, Mrunalini, ready?
Yes, sir.
हा व्हिडिओ चालू करायचा. व्हिडिओ चालू करायचा.
केलाय सर.
हा ओके. एक मिनिट. स्क्रीन शेअरिंग करतो मी. स्क्रीन दिसते का बघ? ओके.
नाही सर. हा सर दिसते सर.
Okay, we can start.
Good morning, sir. Good morning, everyone. Welcome to my seminar. Sir, next. First of all, I introduce myself. Myself, Miss Mrunali Shashikant Patil from BSc 3, studying in a department of chemistry. Today, I am going to deliver a seminar on adsorption theory. Sir, next. Here we can see the content regarding to the adsorption theory. First one is the introduction, second one is the definition, third one is the example, and last one is the merits of adsorption theory. So next. First we see the introduction. There are two important mechanisms or theories which explain the phenomena of a catalysis are first is intermediate compound formation theory and second is adsorption theory. In previous seminar, we have studied intermediate compound formation theory, which explain most of the aspect of homogeneous catalysis and some of the heterogeneous catalysis presented by Shivani. In this seminar, we are going to study adsorption theory, which observed in a heterogeneous type of a catalysis, where reactant are in a liquid, where reactant are in a solid state and catalysts are either in a liquid or in gaseous state. So next. Before going to study adsorption theory in a detail, first we see the basic terms. First is the adsorption. Adsorption is defined as the deposition of a molecular special onto the surface. Common example of the adsorption are clay, silica, gel, colloids, metal, etc. Next is the adsorbate. The molecular species that get adsorbed on surface is known as a adsorbate. Next is adsorbent. The surface on which adsorption occurs is known as a adsorbent. Last is a desorption. The removal of a dissolved substance from the surface is called a desorption. The next. Next is adsorption theory. This theory was proposed by the scientist Faraday in year 1883. The theory that is suggested for the mechanism of a reaction that taking place in a heterogeneous type of a catalytic reaction known as the adsorption theory. The scientist Faraday has suggested that there is a formation of a adsorb activated complex between reactant molecule and the surface of the catalyst. Here, the reactant molecules are temporarily adsorbed on the surface of the catalyst. After the completion of the adsorption and reaction, desorption takes place and they can form the product and catalytic surface made empty for other molecules to get adsorbed. So next. For better understanding of this adsorption theory, we see one example. If we take a nickel as a catalyst and suppose A and B are a reactant, then the mechanism of adsorption theory of heterogeneous catalysis involves following steps. Step first, adsorption. In this step, reactant molecule get temporarily adsorbed on the surface of the solid catalyst or form a loose bond with the free valencies of the catalyst, but there is no reaction taking place in the reactant molecule. Sir, next. Sir, second step.
एक मिनिट. Huh.
Second step is intermediate complex formation. In this step, adsorb reactant molecules on the surface of the catalyst react with each other and form a new stronger bond, leads to the formation of an intermediate. So next. Third step is a desorption. In this step, intermediate converts into product and it loses a affinity towards the catalyst. The product molecule get adsorbed from the surface of the catalyst. Now nickel catalysts have again empty valencies known as the active centers. All the physical irregularities present on the catalyst surface, they act as the active centers, and also free valencies act as the active centers. Active center possesses a small fraction of the total catalytic surface, and hence every small quantity of a impurity or poison is sufficient to inactivate the phenomena of a catalyst. This particular fact is proved by the Faraday. Last part of this seminar is merits of the adsorption theory. This theory explains heterogeneous catalytic reaction. Second is small quantity of a catalyst is sufficient because catalyst is regenerated again and again. Third is the role of a promoters and catalytic poisoning in the reaction. So next. Thank you so much all of you for listening my seminar patiently. And if anyone have doubt regarding to this seminar, then they can ask. Thank you, sir.
Okay. Very nice.